Hi everybody, it's crazy, it's Sunday, and it's time for the UPBGE video of the week. Now before I get started, gotta give a shout out to my trusted, because you guys rock. To my crazy fam, I love you guys. Now we're up to episode number 141, and last week we left off with level of detail on page 26 of the game engine book. If you don't have it, go to the description, it's down in there. Make sure you get the files. The files are very important. Speaking of files, the file we left off with last week was normal map dash finished.blend. Okay, and that's when you take a low poly mesh and you created a texture, okay, of a normal map that placed it over the low poly mesh. Okay, if you don't remember watching that video, go back to 140 and watch that video, because it's kind of a good one to watch. All right, so without any further ado, let's get started. Level of detail. Level of detail, LOD, if you ever hear that term, is a general term referring to ways to adjust the complexity of the object depending on its perceived size. The idea is that objects farther away are smaller and generally less significant to the gameplay. Therefore, they can often be removed or simplified. Ideally, LOD requires computing the size of the object on the screen. Because this is usually very difficult to achieve, LOD is commonly done by looking at the distance between the camera and the object. For a complex mesh, you can create multiple copies of the same model with decreasing complexity. So when an object is a certain distance away from the camera, you can ask Blender to swap the mesh to a less detailed version. Additionally, as the object gets farther away, you can even set the object to invisible, which avoids rendering that object completely. Unfortunately, Blender does not have a built-in support for LOD, so you have to create your own with Python. Actually, they do have an LOD in Blender and also in UPBGE. This, like I said, this is an older book, so at the time of the writing of this book, they never updated it to emphasize that, yeah, there is support for it now. All right, so you can do it's actually better to do it with Python because it can actually do it all in the background without having to fight with Blender. Okay, but there are different ways to do it. So a reference implementation of a LOD system can be found at chapter 8 LOD.blend. Okay, so let's go on over here to our file, hit open. We're going to go back to chapter 8, make sure you're in it, and come on down here to LOD.blend. We're going to open that up, and as you see, there goes the LOD.blend. Okay. Alright, this implementation uses a small script that keeps track of the distance of the object to the camera and places the mesh with a less detailed one as the distance decreases or increases. Okay, and I'm going to switch over here to show you that it's talking about, yeah, I think no, I don't. Yay! Usually I'm usually over here, like, hiding something, but yeah, it's just empty. This is the smallest one. This is the farthest distance. So as you see, it's really nicely detailed. Not so perfectly detailed, really shallowly detailed, and yeah, this is just a shape. Okay, so as it gets farther away, it will reduce it. And this one's got 4. Sometimes you can do 5. Sometimes you can do 7. It depends on what, how far of a distance you want it to be able to render certain objects. If you're doing like a building system, anything behind a building can be set to invisible while you are not behind that building. As you walk around it, it will put that building in place. Okay, so you can do that as well. All right, so let's switch back over here. All right, so the script should be a good place for you to start tinkering with your own LOD implementation. Okay, so what it's saying is this script right here can actually help you navigate through it. Okay, it will create an LOD system. Okay, and that's LOD scale is 0.2, which is basically 0.2 Blender units. Okay, it says controls the aggressiveness of the LOD algorithm. Higher number is higher quality. Okay, so you're going from low quality up to high quality. Alright, and then you're going to do this. And make sure you always do tries. A lot of people don't do this. The tries actually help you out without creating an error, because sometimes it'll give you an error. And now your game crashes because you didn't try it out first. So try first, okay? If you get an exemption error, then it's going to print the error, okay? So to let you know, oh, there's a problem, but it will continue on without it, okay? Because it can still render your stuff the same way. It's just that it's not going to use the LOD factor, okay? And, you easily swap the mesh. And Blender actually has it in it now that you can actually do LOD. And I cannot remember for the life of me for the moment where it's at. I believe it's in object mode. It was in one of these, so look around. You will find it. I'm not sure exactly where it should be in any of those. It might be in world, but it's in one of these. Look in your top level to see if you could find them. If you have a newer version of Blender, or you're using the 8.8 plus version, I'm gonna say, because I think they're almost up to 9 now. I'm pretty sure they have an LOD feature, but most of it isn't for gameplay anymore. It's just, you build your model and stuff, and then you can port it back to Blender 2.79 versions, because for the most part, they're not doing gaming anymore. So there are some people that are working on games in 2.9, or actually 3.0 for those people who use UPBGE. Okay, so there are a couple people on the UPBGE server that are working on making games in UPBGE, but it's not so great. Okay, so the next one we're going to go on with is, am I being too loud? If this is too loud, let me know in the comments, okay? Because I keep seeing it pop over in red over there. Alright, so object culling. To make the game run as efficiently as possible, objects that are not visible should not be rendered. While it might be obvious that everything behind a solid wall should not be processed, the computer will need a bit more help to accomplish that. Okay, so what it's talking about is something behind a wall. I'm going to switch over to here. Oops. That one. Okay, anything behind a wall shouldn't be rendered. All this stuff over here should not be rendered while you're looking at the wall. Now this one and this one should be rendered. That one shouldn't. That should. The only two that should be rendered is these little guys and this picture way over there. Okay? To help the game engine cull objects, set up occluders to hide part of the scene from view. For example, occluders can be used to mark the separation between an indoor scene and an outdoor scene. A simple file provided at chapter 8, KILLxxTHISxGIRL. So let's go back over here. We're going to go over to KILLxxTHISxGIRL. Let's hit open. Let's see if we can find KILLxxTHISxGIRL. There we go. Okay, which is the same thing we saw over there. Okay, anything out of screen will not be visualized. Anything in screen will. Okay, so anything you can see past a wall. And they've got culling set. Okay, they have an occluder set, physics type occluder. Okay, and you can set it to invisible, I do believe, but let's follow along here. The effect of culling is shown in figure 820, which I just showed you. Okay, to see the effects of occlusion culling, make sure that you are in wireframe view. So let's go over here to wireframe, make sure it's in wireframe view. First, run the sample file. Notice that everything inside the house is visible, even when the camera is outside. This is because there is no occluder object. Okay, so we hit, let's go over here and hit. I always do the standalone player, because if you do the internal player, it will mess up. Oop. As you see, I am now upside down because I flipped everything over. Okay, so let's hit escape. Minimize that. Let's try it again. Okay, as you see, everything is there. It's very sensitive. Okay. Now, everything inside the house is still there. It's just that you will not see it, back up, until you get to a certain point. Okay. There we go. Okay. Unless the camera is seeing on it. So that won't, it won't occlude these objects. These objects are still there because nothing is occluding. Okay, what's going to occlude it is, you come back over here to physics, will probably be the house. First, from the sample file, notice that everything inside the house is visible even when the camera is outside. This is because there is no occluder object. Now, set the wall occluder object to be an occluder and rerun the game. Notice that the wall effect hides objects inside the house until the camera is inside. So, let's see, should be wall occluder. Should be, no, it's cube. Toggle occluder. It's got it all set, but oh, you gotta hit the space bar. Okay. So we're gonna go ahead and go. They've already got it set for some odd reason. If we hit start and hit space bar, so do it. Okay. Not understanding that. So now set the occluder object to be the wall occluder object. So there should be a wall occluder object. So we're going to switch over to outliner. We're going to look for the wall occluder object, which doesn't show one. It shows the monkey and the cube, which being the camera. So there is no wall occluder object. To return to rerun the game, notice that it doesn't show it. Keep in mind that the culling is done on a per object basis. Blender will not hide part of the model. Therefore, occlusion culling is effective only when there are many small objects in the scene hiding behind a large object. Okay, so I kind of don't get that because it shows all the occluder information here. Let's see here. Yeah, and that's all they've got. So, I mean, oops, I did the wrong one. Let me go back and culling. Okay, it should be, when you hit play. Okay, you see that they all disappear. I don't know why I wouldn't do it the other way. Okay, so we got to turn on the occluder object, which I guess is the house. So we hit space bar. Let's hit play. Hit space bar. Okay, you'll see everything appear. So what it was is I'm used to the standalone. The standalone, it automatically does it. It shows you what it does actual render, but this shows you what you've got as scene if you just hit play. But you can, every time I hit space bar, they either disappear or reappear because the occluder is on. Okay, which is set that if you hit the space bar, it turns it on and off. It changes the visibility to them. That will actually save you some render time. So I don't have that set on. So if we go over to our render properties and we come down here to in render frame rate profile. Okay, you can set the frame rate and profile in properties, and then when you play it, it will put it up there. Now you'll see the rasterizer. Okay, watch the rasterizer. It's at 0.5, 0.3 because I'm running a pretty fast system. But as you see, because my system's really quick, it literally doesn't make any difference, but those can actually save you if you have a lot of stuff and you got buildings in the way and stuff like that. You can make those buildings occluder objects, everything occluder, so that way when you walk through and your character's walking, it won't see until you get to a certain area. As you see, it occludes until you get inside, which actually that shouldn't be showing those, but you should be able to see them all once you walk into a building or catch to another scene. Like that one shouldn't be seen because if it's out of view, it should occlude itself. Okay, things like that should occlude. Okay, all right. So let's go to scene management. Optimization isn't just about making your game fast. It is also about keeping the project organized and easy to manage. As the game project becomes larger, it gets progressively harder to keep everything organized. Here are some things you can do to maintain your own sanity. Linked libraries. The size of a single Blender file is virtually unlimited, so in theory, you can make a massive game with everything stored in one Blender file. However, this approach is not practical for many reasons. Only one person at a time can edit a Blender file. So how do you spread a large project out so that multiple people can work on different aspects of it at the same time without overriding each other's work? The answer is Blender's library system. You have already been exposed to linking and appending in Chapter 2. It's a system that allows you to bring in data blocks such as a character model from other Blender files into the current file. This way, each asset can be worked on at the same time separately. This also makes reusing of assets easier. The game Yo Frankie, available for free online, is a great example of how a large game project is organized. In it, each entity, for example, tree, character model, and rocks, has its own Blender file, which can be linked into the master file, which makes up the game level. Linking versus appending. Both functions import data blocks in Blender from an external file. The difference is that appending makes a copy of the data block, and in doing so, severs the ties with the original library file. Once an append operation is done, you can edit, move, or even delete the library file without any consequences on the appended object. Link does not make a new copy of the data block, but instead references the library file every time the master blend file is loaded. This way, changes made to the linked object will be propagated to the master file. Okay? Linking is generally preferred over appending since it doesn't replicate the data blocks. The only time you should append something is if you want to be able to use that for something else. I've done that a couple times. Linking is like how my HUD is on my game. I want to link it, but I don't want to change it. If you want it to stay the same without it being changed or reverted, then you will link it. Okay, like character files, you should link them instead of copying them over, because it will change that character. If you change any aspect to make it move to a new animation, then that linked object is not going to do the same. Okay, because you appended it over. So be very careful of that. All right, relative path versus absolute path. Once you start referencing external files such as image textures and audio files into a project, you need to decide if you want Blender to point to that file using a relative file path, the default option, or an absolute path. Generally, keeping paths relative means it's easier to move a whole project around as long as the overall folder structure is maintained. If multiple people are working on the project jointly using a file share or source management system, using relative path is absolutely critical. Okay, Blender has some helpful tools under the File, External Files menu that can let you manage file paths. Okay, Street Lamp versus Cube.001. Yeah, I've got a lot of those. All right, so a scene teeming with objects with unhelpful names like Cube001, Cylinder .80, so it should be 0.87, and Material.002 would be a nightmare to manage. First, scripts that refer to objects by their name will be harder to understand if object names aren't clear. By keeping everything named, you reduce the time it takes searching for something. Assigning proper names is not only limited to objects, all data blocks in Blender can be renamed. This includes objects, object data, lamps, materials, textures, and image data blocks. Renaming everything might seem like a lot of work, even borderline OCD, but once you are used to it, it really does make the project easier to manage. Think of the poor intern who has to pick up your project 6 months later. Okay, naming your project should be very important. I'm kind of OCD with stuff, but my buddy Day is more OCD than me, and he names everything, and which is a good practice to get into. Even naming these guys right here, okay, always helps. Because you'll know if you just have keyboard and you've got 5 keyboards, it'll be keyboard.001, keyboard.002, and so on and so forth. And so you're not going to know that this one's the space bar. If you just click on here and just type space, or even bar, space bar, okay? Now, when you minimize this, you can't tell what it was, but you can tell by this name that, hey, if the keyboard space bar is pressed, then you get all this happens. And it'll do this toggle, it'll do this occluder, and it'll do this occluder. So it'll either make it visible or non-visible, depending. Okay? And, you know, of course, you're going to be using different extensions, which is your occluder. All right? So naming stuff, and especially not naming it, like, I got stumped because it's saying Q01, or Q, and they're talking about a occluder object, and the occluder object is actually this object right here. So it's actually Q. And if you wanted, you wanted to say Susie, well, you've got, what's the name of this one? This is Monkey 03, Monkey. They're all Monkey, and you don't know which one is which unless you're looking at the thing down here. But if you're in the game, how do you know which one's which? Naming them, so that when you come back, you're like, it was this one, so that was Monkey 005. You could be blue monkey, red monkey, green monkey, purple monkey. Name your stuff. It helps. Because having just camera sometimes is not a good thing. Having just cube is not a good thing. Alright, you want to name stuff so that you know that this is your building or your house. This is the ground, not a monkey. So you click on this and you're wanting to click on the monkey and that's a plane. Well, it could be considered a plane because it's made up of planes. Logic will dictate that, hey, name your stuff. Name your stuff helps out a lot. Okay? Alright, so, yeah. Let's see. Let's see how far I'm... Okay. Alright, I'm going to go ahead and finish this out. I know we're running a little bit long in the tooth, but this is going to be the end of Chapter 8, so I'm going to go ahead and finish it off. So, layers. Not unlike the layer functionality in a 2D image editing program, the layer functionality in a 3D program is mostly there to keep the scene organized. Blender provides 20 layers for you to work with. How these layers are utilized is up to the artist. Since you cannot assign names to layers, it will be up to you to keep track of and perhaps document how the layers are being used. Okay, I'm going to say that because I usually use this one as a trash layer and this one as some other layer, and use the rest of these for like putting like buildings and different landscapes and different things, like tree LODs and stuff like that. So that way you're going to hit shift and you'll highlight these if you want them to be used in your scene. Okay, because if I put like all the Susies, okay, if I go over here to Susie and I click on all these Susies, I think I got it. Yeah, nope. There we go. Okay, we'll click on all the nope, not the house. The Susie, there we go. Susie back there. Undo the house. Okay, if I wanted to take all the Susies, I just hit M, and I'm going to move them to this bottom layer right here. As you see down here, now they're there. Now watch this. If I just click on this one, everything disappears. Okay, so now I want to move the house back to... back up here. There we go. Okay, so now I'm on here, all I see is the Susies. Okay, even that Susie over here, I can move him. Okay, now so let's put that Susie out there. Okay, because we're not really caring about that Susie. All right, so when you put them on, now everything pops back in. So if you ran this file right now, and I hit P, the only thing I lost the box. Here we go. All you're going to see is the box. Where did all the Susies go? Because you don't have them linked up in this deal here. Now let's go shift and add them in and then hit play again. As you see, now all the Susies pop in and you can see them except for the one over here. Oops, my mouse isn't that great. Okay, so now if I click on this one and do it, it does the same. You'll be able to see it if I hit play. Okay, see? The Susie pops in. Alright, so that right there actually helps you out later on time. Okay? Beauty trumps complexity. Armed with these newly acquired optimization methods, you might be tempted to beef up the game with more details. more polygons, higher resolution textures, large explosions, cough, cough, cough. Michael Bay, cough. It's easy to lose sight of the big picture. A visually beautiful game does not have to be photorealistic, nor does it have to be crammed to the brim with details. Sometimes simple visuals can be just as powerful. Okay, and I'm going to switch over to here. Oops, there we go. And here goes some stuff below. Below are a few games that are faithfully to the adage that less is more. Journey, Limbo, and Love. These 3 games are pretty good. Journey, I actually played that game. I love that game. That game's a really good game. My wife enjoyed it. I enjoyed it, and it's a really good game to play. Limbo, I've never played it, but if you want to check it out, these 3 games right here, okay, were all done with less is more in mind. Okay, so you can get a visually stunning, game without all the complexity. Okay, so that's going to end our chapter 8 for this week. Let me see if I can switch back to here. Okay, so we're at the end of chapter 8. Next week's going to be chapter 9, so pay attention to that because we're going to be starting a whole new thing. We've got 2 more chapters left, and hope y'all follow along for the last 2 chapters. And when we get done with that, we're going to try something else. So, till next week, chapter 9, it will be a whole new chapter. We finished off this chapter, and I hope you learned a little bit. If you have, that's great. Jump on over to the server and say, hey, I learned a lot. Or let me know in the comments. Jump down there and say, hey, crazy, this is great, whatever. Whatever floats your boat, okay? But if you learned something, that's great. I'm glad you learned this because optimization is very important. So, till next week, chapter 9. Till then.